Hi there, Robert. This is what I've done so far. I've been working away on the brushed motor reversing pump, and this is the kind of motor I'm using. It's a fairly standard, this is a Mabushi motor 380S, so it's actually a little bit powerful for this, but there's lots of these 380 motors around, and I think these are the ones to use. The most important thing about this motor is, of course, the width, is the thickness of this, which is 2.26 millimeters. They're all much the same, and this critical width here, which is 6 millimeters. So I built this around this just to well, I was going to say too, the other issue is the length of the shaft, because that tells us, you know, how much we can build on top. So the first thing that I've done, and we'll look at this in a moment in some detail, is to build the mounting for the motor. And the critical parts about the mounting for the motor are the accuracy of these two little things. It's always been very difficult for me to do it, but with 3D printing it should be much easier indeed. So I've put this little groove in here which basically takes care of these little mountings. They're on all of these particular motors, and that screws into here like so. There's a little groove in the middle of this too, another little slot, and on here goes our O-ring, and then onto the O-ring we screw this, and this is the holder for the impeller. Now two screws go in here, screw it all together, and as it screws it together it pushes down the O-ring, and this thing won't leak at all. Once you've done that, this is the little impeller that I've made. That clunks onto there. It's got a little bit of a gap at the bottom so that it doesn't touch the screws, and then we just have to put a cover on there. The final thing, and I'll take that off just to show you this, is that this is PVC pipe that you get from any hardware store. It fits into here and pushes very nicely down inside this, and the idea is that we just glue that on, and people can make it any length that they want, and then once they've done that, I've made this little contraption here with another little O-ring that slips over there, slips onto there, and this whole thing is beautifully sealed and will run exceptionally well. I'm not going to put it all together right now, but I thought I'd show you the bits first. So let me show you, to begin with, this one. Okay, so here it is. This is our little gadget, and this is how it all looks. So you can see from the side, I've made it 17 mil thick. Doesn't have to be. I just made it that thickness so that I've got plenty of room to push the PVC pipe in. But the actual interior dimension on this is more important than the exterior, because this makes that connection. And the interior dimension is 33.6 millimeters. Okay, we go down, we've got these two screw holes at 16 millimeters across, that's from the centers, and they are 2.35 millimeters for a 2.5 mil screw. This little one in the middle is where the prop shaft goes, and it's 2.3 across. It's got a little bit more slack in it because we don't actually, that's not the sealing agent, that little screw in there. So over here I've got the bigger picture of that. It's 2.3 mil. The slot in here for the O-ring is 5.6 across, and it's 1.4 millimeters deep which leaves us here around about 1.9, about 0.9 of a millimetre actually taking all of the weight. That's obviously not drawn very well, but gives you, they are the dimensions. So going back to this, we've got, if you do that at 17, we need 11.3 in here, because basically what we need is a slot in here for the motor, which is 10 mil across and 3.3 deep. So have you got that? We've got, this is the critical area around here with all of that stuff. Now if we're looking now down onto this, or is it up? Can't remember. Doesn't matter. We've got the centers here at 16 millimeters, 2.3, it should be 3.5 for those. We've got the inside dimension at 13.6, the outside is 13.8, but then that's not particularly important. As I said, it's fairly flexible. And that's basically how this sits, and if you can make one of these, fantastic. Right, now here comes the next piece, and what I didn't show you are these little holes that run right the way through, and this is where we mount the inlet and the outlet from the pump. Thing about this is I've made this square so that it can be screwed into any sort of position, and I've also just put the holes in there, and people really can drill them out and make them as big as they want. It's not really critical, but it might be useful to have some flexibility. So I'm going to suggest that we put a hole in here which is actually a little bit less than the one that I've got here, so people can drill it to the material that they've got. Okay, let's have a look. So as you can see, the total width is 10.3. No. The total width of this is 11.3. I think I've put that a little bit of an extra 0.3 into here, just so that we can better fit the impeller. So it's 11.3 out there, it's 10.3 right the way through, and we've just got 1 millimeter thickness at the bottom of this. If you look at the side of the square, it's 40 millimeters, and the circular hole in the middle is 31 millimeters, and these holes are identical to the holes that are in the piece below, so we can screw the thing together. I decided that rather than try and put any countersinks on these holes, we'll just leave them as they are, and we'll make the impeller a little bit bigger so that people don't have to worry about it. But that's part 2, and I hope that's all clear. Okay, now here is the little impeller, which is just the same as what I built for my other pumps, and I use super glue, sort of strong super glue, to get these little plastic strips in, and I just cut the slots with a saw. It's as simple as that. So you can see I've got that little extra step at the bottom to miss the screws coming through, and we've got the little hole in the middle. So the way this works is, and once again this is relatively arbitrary, I could make this a little bit thicker actually, which I've done in this diagram. So the outside of this is 15 millimeters. I've got, it's 9.8 high in total. I've taken 2 millimeters of that off and reduced that down to 11, just so the little slot sits there and we miss the screws. And the impeller parts are 5.5. I've made them a little bit bigger than I have on here. Now the thickness of this I'm going to leave to you, because it depends on the plastic. We don't want them breaking off. There's a fair bit of distance between them and the edge of the pump itself, and the water can move around that. I've discovered already if I put these right up to the edge, something's going to break. So there's plenty of room for that for the water to move around and develop a very nice movement within the impeller. So that's it. Now the critical factor is this central bore. And what I'm going to say is that this should be 2.2 mil because the actual width of the whole thing, of this, is 2.5. Let me just double check that. Yeah, 2.5. And I want this to be quite a nice press to push on. Now the other issue, and I'm not sure about this, we'll see how we go, is the notion of putting a drill right through the middle, which would be probably something like a 2.8 drill, and putting a 3 mil grub screw, one in there and one in there, and possibly mounting that right, well obviously it will be right in between two of the impellers. But for now, maybe not. What I'm going to suggest, if you can do it then, just run that right through the middle. And we're looking at probably, keep it lower rather than higher, we're probably looking at around about 4 center in the middle of this. There's a number of reasons for that. Make it 2.8 so that we can get a grub screw in there without any tapping or anything like that. That might be a good idea. Okay. Okay, now this is the little cap that runs at the end, and you can see that I've drilled, or I've cut into there, the slot for the O-ring. The most critical part of this is the depth of that O-ring, 23.06. The outside of it, the other critical factor is the width, which is 3.5. That fits this O-ring perfectly and gives a nice clunk up within that thing. So the size of it is 34 mil. I've divided this into 3.2, so we've got 3.2 here, 3.2 here, we've got 3.5 here for the O-ring. We continue with the same width for just another 2 mil, and then cut it off. So the thickness of this is 29.3, and the bottom, or the thickness between the grooves for the O-ring, are 23.6. There we go. Alright, so I guess the next step will be for you to have a look at this and tell me how doable it is. Then make it up, send it to me, and I'll come back to you with possibly some suggestions. But I think this is all pretty good. The question of the water tightness is really nicely answered in this. I think it's going to be fantastic. Anyway, thank you, and have fun.